Okay, so you've all been working on these problems for a while in your groups. Let's take a look at how to do them, and you can see how you did. I'll just move this around a little bit. So we don't have too many of these gradient signs in this part of the country, but if you drive in more, especially more mountainous areas, you'll see gradient signs that are really important, especially for if you're driving a heavier vehicle like a semi-truck or something like that. So if it says a 20% gradient, we've been talking about slope and rise over run. So 20%, that means a rate of change of 20 over 100, 20% out of 100%, or you could think of it as a rate of change 1 in 5. And we've been talking about slope being rise over run. So in other words, what that means for that road, for that section of the highway, that the rate of change is 1 in 5. In other words, for every 5 feet or 5 miles, whatever that you go for run, you're going to rise 1. So it's 1 in 5, or 1 foot up for every 5 feet that you go. Okay, so we'll label that on here. We'll just use feet for this. So the rise is over here, and the run is here, the bottom leg of our right triangle. Okay, so if we're going to drive 8 miles, that's actually, for our triangle, we use this larger triangle here, that's actually right here on the road. Here's the part we're driving on. So here's our little car. We're driving up the road 8 miles. It's a 20% gradient. Now, if we need to figure out the rise, if you notice, this is actually on the hypotenuse of the triangle. So we first need to use the Pythagorean theorem to figure out the hypotenuse of the triangle. So if we take our 5 squared plus 1 squared equaling c squared, c will be our hypotenuse, 25 plus 1, so 26 equals c squared, square root both of those. So the exact length of this is the square root of 26. And let me just erase the c there. We use our calculator to get that approximately. So let me just use that. So we want the square root of 26. So that's approximately 5.099. And so if we want to be, we'll just leave that on there. I'll just put approximately 5.099, which may not seem like much of a difference between 5 and 5.099, but if we start using thousands of feet, if we're covering miles and we're changing it into feet, thousands of feet, that 0.099 can make a big difference so that we're more accurate. Now we look down here, 8 miles. We're trying to figure out our rise, so I'll just call that x. So enlarge that. We'll write a proportion. We'll write that over here, so we'll just compare here. So we've got 1 is to x. 1 is to x as 5.099 is to 8. We'll just write ratios with the corresponding parts of those triangles. So 1 is to x as 5.099 is to 8. Okay, so to solve that proportion, we would take 8 times 1 times 8 divided by 5.099. And to be most accurate, we'll go back to our calculator. And I left the whole answer on there without rounding it at all. We wanted to take 8 and divide it by that amount. So we're going to take 8 and divide it by our answer. And that's our most accurate answer there. Now that is in miles, 1.568 miles. So we can fill that in. That's our elevation gain in miles. So we're gaining a little over 1.5 miles in vertical elevation. And so we want to multiply that by 5,280. And here's then our elevation gain in feet. So approximately 1.57 miles. And approximately that's 8,283.95 feet. So we gain a lot of elevation if we drive for 8 miles at a 20% grade. Okay. So that you could have filled in the blanks there. Okay, let's take a look at our next problem. We need a wheelchair ramp with a pitch of 512. It's got to have a rise of 18 inches. So a 512 pitch, it's kind of like the gradient on that road. We want a rise of 5 and a run of 12, or in other words, we want whatever we build, it's got to be in that ratio, that rate of change. So if we want our ramp to have a rise of 18 inches, we want to figure out what our run is going to be. So that'll be x. So set up our proportion again, just set up ratios with the corresponding parts. 5 is to 18 as 12 is to x. So I'll cross multiply 12 times 18 divided by 5. So I'll just do that without going to the calculator. So 18 times 12 divided by 5. So we get 43.2. So we need a run of 43.2 inches in order to have that ramp have the proper rate of change, the proper slope. Okay, let's take a look at the next one. Got a drastic change in temperature from daytime in the desert to nighttime. Gets a lot colder at night. So if you remember from yesterday, we were talking about slope being rate of change. We want to find the average rate of change. So remember, rise over run, we're going to do change in y. In other words, in this case, we're going to do the temperature over the change in x. So that's going to be our time in hours. So the temperature went down 32 degrees over a time period of 15 hours. So that gives us an average rate of change. If we just take negative 32 divided by 15, that's approximately negative 2.13 degrees per hour. So it basically drops 2 degrees per hour. A little bit over 2 degrees. Okay. We talked about the slope formula yesterday. Remember, we find our m by just taking y1 minus y2 over x1 minus x2. So if we do that here, negative 8 minus 1 over negative 3 minus 5. So we get negative 9 over negative 8, or we'll just say a slope of positive 9/8. Okay, do our next one here. It doesn't matter if I went left to right on the first one, but you can also go right to left. Let's do that on this one. So negative 4 minus negative 4. Negative 3 minus 6. So it's negative 4 plus 4. It's going to be 0 over negative 9. 0 divided by negative 9, that's just a 0 slope. Okay. 7 minus 4. Subtract the y's. Negative 10 minus 5. So 7 minus 4, that's 3 over negative 15. We always want to put our slopes in lowest terms, so I'm going to say negative 1/5. That way we're consistent in the way we give our answers. So negative 1/5. Let's take a look at our last one. 1 minus negative 6 and 8 minus 8. 7 over 0. Now, you're probably remembering the first of the 10 commandments of math is that you cannot divide by 0. So that's what we call an undefined slope. That tells you it's a vertical line between those 2 points. Okay. So those are our answers for those. When you plot those 2 points, if you were to plot these, also you'd see, so we get 8, 1 and 8, negative 6. So it's a vertical line through those two. You can see it visually too, that that's an undefined slope. It's vertical. Okay, let's take a look at these and see what patterns we notice. We've got y-intercept is negative 4. Slope is 2/3, so up 2 over 3. Okay. And what we'll do is we'll use our line tool here to draw a nice line. So let's see. Just let these look a little bit nicer. Okay. And then the next one, plus 5. So 1, 2, 3, 4, 5. Y-intercept is 5. Slope is 2/3 again. Same slope, so the lines are going to be parallel. So those two lines, since they have the exact same slope, they're never going to intersect each other. So those are parallel. Let's take a look at the other pair. We've got y-intercept of 2. Slope of positive 5, so it's up 5 over 1. So 1, 2, 3, 4, 5. Okay, pretty steep slope. The other one, let's draw that. Okay, the other line was y-intercept of 4. And that was a slope of negative 1/5, so it's down 1 over 1, 2, 3, 4, 5. Down 1, 1, 2, 3, 4, 5. Okay. So you can probably see this already. These two, you could get out a protractor and measure that, but those two are exactly perpendicular. The angle between those two, where those two intersect, is 90 degrees. So if your slopes are, if you look at your slopes, and if they're what we call the negative reciprocal, in other words, you're going to take the reciprocal of the fraction and change the sign. If it's the negative reciprocal, that tells you those lines are exactly perpendicular to each other. Okay. And our last problem here, I want to find the x and y intercepts. A quick way to do that, we know where it crosses. Whenever you have a line where it crosses the y-axis, say take this point right here, the x-coordinate of that point is 0. Say take this point right here, that's 5, 0. I'm sorry, I wrote that the wrong way. 0, 5. Every point on the y-axis, the x-coordinate is 0, and the y-coordinate is the intercept. So if we wanted to find the y-intercept, we'll just set x equal to 0. If we take a look at that up here, if we set x equal to 0, 3 times 0 would be 0, our y would have to be negative 12. Okay? And if we set all the points on the x-axis, those have a y-coordinate of 0. For example, like -3, 0. So if you set the y equal to 0, you'll get the x-intercept. So set that equal to 0. I'll use a different color here just to differentiate between those two. Set the y equal to 0. Our x would be 8. Okay? So if we wanted a quick way to graph that, we could just use our intercepts. The x-intercept was 8, 0. The y-intercept was 0, -12. I'm going to be a little off the board here. And this would be, just draw a real rough line here. That would be our line with an x-intercept of 8 and a y-intercept of -12. That's another way that you can graph without having to put it into slope-intercept form. If usually I just look, and if this number over here is divisible by both of these two coefficients, it's a nice quick way that you can just find the intercepts and draw a line. Okay, so if you figured those things out in your group, you're doing an excellent job. You can now start working on your book work for sections 2.2 and 2.3.